Hey there, tech enthusiasts. Get ready with Eglovert to rev up your coding engines because today, we're diving headfirst into the exhilarating world of Python frameworks and libraries. Python, the powerhouse of programming languages, is not just versatile and beginner-friendly, but it's also armed with an arsenal of pre-packed libraries that'll turbocharge your development process. Alright, folks, it's time to buckle up as we kick off our thrilling journey through the best Python frameworks and libraries. And what better way to start than with the undisputed champion of web development frameworks, Django. Django, the superhero of high-level web frameworks that's captured the hearts of developers worldwide. It's impossible to compile any Python framework list without including Django. So, here it is, taking the center stage. Embracing the Model View Template (MVT) architecture, Django organizes your code in a way that promotes reusability and maintainability. It takes care of database management, URL routing, template rendering, user authentication, and more, so you can channel your energy into building robust and scalable web applications. Let's talk about impressive list of key features that Django has to offer. Django, a popular web framework, offers several key features for efficient web development. It includes an object relational mapping system to simplify database interactions using Python objects. The MVT architecture promotes code organization and reusability, while the robust URL routing system maps URLs to views. Django's template engine separates presentation logic from business logic, and it also provides built-in form handling with features like form validation and error handling. Now that we've seen what makes Django the talk of the town, let's explore some thrilling use cases where Django shines like a beacon of light. From web application development to content management systems, e-commerce platforms, and even data analytics and visualization, Django's versatility knows no bounds. It's a go-to choice for building APIs and web services, and social networking platforms too. Django can do it all. But hey, as with any framework, there are always pros and cons to consider. Django, the high-level web framework, offers rapid development, scalability, security features, an administration interface, and the support of a strong community. However, it comes with a learning curve, complexity for small projects, limited flexibility, performance overhead, and some ORM limitations. With its exceptional benefits and minor drawbacks, Django remains a top contender for building robust and efficient web applications. Second on our list, we have Pyramid, the lightweight and flexible Python web framework that puts simplicity and customization front and center. With the minimalistic approach, it gives developers complete control over the application's structure and components. Designed for scalability and performance along with various features including different URL patterns, supports multiple templating engines, and built-in features for authentication and authorization. In addition to all this, it also has comprehensive documentation and an active community, making it a popular choice for developers who are looking for customizable Python web dev frameworks. Let's discover a plethora of Pyramid features that cater to diverse needs. Pyramid, a flexible web framework, stands out with its simplicity and minimalism, allowing developers to add components as needed. URL dispatching is a powerful mechanism for handling diverse URL patterns and HTTP methods. It supports multiple templating engines, facilitates authentication and authorization for secure user access, and offers flexible configuration options. And more. Now, let's explore the captivating use cases where Pyramid truly shines like a gem of adaptability. From crafting custom web applications to developing content management systems and building APIs and web services, Pyramid does it all with ease. But that's not all. Pyramid is your go-to choice for creating single-page applications, prototyping and proof of concepts, and even tackling enterprise-level projects, etc. So, without further ado, let's explore the advantages of Pyramid. With its focus on flexibility, minimalistic approach, scalability, extensibility, robust debugging and testing features, proper documentation, and a strong community, Pyramid, despite its remarkable strengths, comes with a few cons to be mindful of. Developers may encounter a learning curve when first diving into the framework, and the initial setup might require some effort. Manual component integration can be time-consuming, and the ecosystem, while strong, might be relatively smaller compared to some other frameworks. Note, although the points are listed in cons, they don't need to be drawbacks for all projects which use a Pyramid. They can be pros as well for certain projects. Ultimately, the suitability or usefulness of a Pyramid boils down to your project requirements. Next on the list we have Bottle. The Bottle is a fast, simple, and lightweight WSGI micro web framework for Python. With its minimalistic design and small code base, it is easy to use. The bottle is distributed as a single file module, which helps it in integrating with the projects without much complexity. It is an ideal choice for small to medium-sized web applications and prototyping as it provides inbuilt support for routing, handling HTTP requests and response as well as working with templates. Moving forward, key features of Bottle. Bottle, a lightweight web framework, excels in simplicity and minimalism, making web development straightforward. It comes with built-in URL routing for easy request mapping and handles HTTP requests and responses conveniently. Additionally, Bottle supports various templating engines, offers built-in user session management, and simplifies client file uploads and form data processing. It also provides features for building RESTful APIs and more. So, let's explore the thrilling use cases where Bottle's speed and simplicity truly shine. For small projects, microservices, and APIs, Bottle's agility and efficiency make it a go-to choice for developers looking for a lightweight solution. Single-page applications and prototyping thrive with Bottle speed, allowing you to bring ideas to life in record time. Etc. Let's proceed toward Bottle's pros, which include its lightweight nature, simplicity, fast development, easy integration, and excellent RESTful support. However, it comes with some cons to be mindful of, such as limited scalability, lack of advanced features, a smaller community, limited template support, and a smaller ecosystem. Fourth on our list is Tornado. Tornado is a high-performance Python web framework and asynchronous networking library. This best Python framework for web development is known for its ability to handle thousands of simultaneous connections with low latency. Tornado is popular for building scalable, real-time web applications and APIs, thanks to its asynchronous I/O capabilities, request handlers, templating engine, and integration flexibility with existing applications. Apart from all this, it includes its web server, supports WebSockets, and employs an event-driven architecture for efficient handling of concurrent requests. Moving on, key features of Tornado. Tornado, a powerful web framework, offers several key features for efficient web development. Its asynchronous I/O enables handling concurrent requests and non-blocking operations, ensuring high performance. With a built-in web server and WebSocket support, real-time bidirectional communication becomes seamless. Tornado's request handler model simplifies routing and handling different HTTP requests, while the templating engine allows for dynamic web page generation. Etc. Now, let's dive into the thrilling use cases where Tornado's speed and asynchronous capabilities truly shine. For real-time applications, web APIs, streaming services, and WebSockets applications, Tornado's lightning-fast performance makes it the go-to choice for developers aiming to deliver responsive and dynamic experiences. Now let's explore pros and cons of Tornado. Tornado's standout pros include its high performance, scalability, real-time capabilities, lightweight nature, seamless Python integrations, built-in web server, and strong community support. However, it comes with some cons to be mindful of, such as a steep learning curve, a limited ecosystem, complexity for simple applications, and the lack of a built-in ORM. Despite these drawbacks, Tornado remains a top choice for developers seeking a high-performance and efficient web framework for their projects. Moving right along, next on our list is Flask. Flask is a lightweight and flexible Python web framework used for building web applications and APIs. It emphasizes simplicity and minimalism, providing the essential tools for web development. With a built-in routing system, a templating engine for dynamic content, and extensibility through various plugins, Flask Framework Python enables developers to create small to medium-sized web applications, prototypes, and RESTful APIs efficiently. It is highly regarded for its simplicity, ease of use, and flexibility, making it one of the most popular Python frameworks. Next, key features of Flask Framework. Flask, a lightweight web framework, enables quick and efficient web development. Its flexible routing system handles various HTTP requests seamlessly, and the powerful templating engine allows dynamic content generation and integration with HTML templates. Flask's extensibility through plugins and extensions makes integrating additional functionality easy, while its compatibility with other Python libraries simplifies collaboration. Etc. Now, let's explore the captivating use cases where Flask's simplicity and flexibility truly shine. From crafting web applications and RESTful APIs to experimenting with prototypes and microservices, Flask is the ideal choice for developers seeking a lightweight yet powerful solution. Single-page applications, internal tools, dashboards, and educational projects all thrive in Flask's agile embrace. And more. Moving on. Flask's standout pros include its lightweight and minimalistic nature, offering a flexible and highly customizable web framework. With an extensive ecosystem of extensions and plugins, Flask is a developer's playground. The framework's well-documented resources, coupled with a large and active community, provide invaluable support. However, it comes with some cons to be mindful of, such as the lack of built-in features compared to comprehensive frameworks, making it less suitable for large-scale applications with complex requirements. And more. Sixth on the list is IOHTTP. IOHTTP is a Python library mainly used for building asynchronous HTTP-based client and server applications. It leverages Python's Asyncio library for the efficient handling of concurrent requests, making it ideal for developing high-performance and scalable web applications, APIs, and web scraping tools. IOHTTP supports various HTTP features like WebSockets, cookies, sessions, and SSL/TLS encryption. It provides an easy-to-use API for making HTTP requests and handling responses asynchronously, enabling developers to build efficient and responsive applications that can handle many concurrent connections. Key features: IOHTTP, a powerful asynchronous web framework, excels in handling asynchronous HTTP requests, ensuring efficient concurrency and responsiveness. It enables developers to build complete web applications by providing both client and server-side functionalities. The built-in WebSocket support allows real-time bidirectional communication between servers and clients. IOHTTP supports various HTTP features, including cookies, sessions, SSL, TLS encryption, content compression, and authentication. And more. IOHTTP, our next contender, is all about asynchronous web applications. This versatile framework has a wide range of use cases, including building RESTful APIs, web scraping, real-time applications, and microservices. IOHTTP's strength extends to proxy servers, load testing, streaming applications, and even IoT applications, making it a top choice for developers seeking seamless asynchronous development experiences. Now, let's dive into the world of IOHTTP and uncover its hidden potential. IOHTTP, the champion of asynchronous web applications, boasts a wide array of pros. Its asynchronous nature, flexibility, and built-in WebSocket support enable developers to create highly efficient and responsive applications. However, developers should be mindful of some cons, including a potential learning curve due to its asynchronous nature, limited ecosystem, and compatibility constraints, which may render it unsuitable for certain projects. Next one in line is Precommit. Last but not the least in our list of Python frameworks is Precommit. Precommit is a popular Python framework and command line tool used to maintain code quality by running configurable checks and fixes before committing changes. It integrates with the version control systems like Git, executing pre-commit hooks on each commit. With pre-configured and custom hooks, it enforces code formatting and style guidelines. Enforcing quality standards ensures clean and compliant code, improving overall code base quality and reducing potential issues. Moving on to the key features of Precommit. Precommit offers a set of powerful features to enhance code quality and development efficiency. It allows developers to configure hooks, specifying tools and checks to run before committing code. Seamlessly integrating with popular version control systems like Git, it automates triggering pre-commit hooks with each commit. With pre-configured hooks for common tasks like code formatting and linting, and the ability to define custom hooks, it provides flexibility to suit project requirements. Let's explore the use case of pre-commit. It is used for enforcing code style, code linting, security checks, automated testing, commit message validation, dependency management, continuous integration, and documentation validation. Moving forward, pros of pre-commit include its ability to enforce code quality, catch potential issues early, improve code consistency, support a wide range of hooks, automate code formatting and linting, allow custom hooks and configurations, integrate with popular version control systems, maintain a clean commit history, and facilitate integration with CI/CD pipelines. Next, cons of pre-commit involve the need for initial setup and configuration, an extra step before committing code. A potential small overhead in commit time, the requirement for developers to adhere to configured checks, occasional maintenance for hook updates, the possibility of false positives or false negatives in checks, a learning curve for setting up hooks, dependencies on external tools for some hooks, and reliance on developer discipline to fix detected issues. 8.1 is requests. The requests library is a popular Python library used for making HTTP requests. It provides a simplified and intuitive API for sending HTTP requests and handling responses. With requests, developers can easily perform common HTTP operations such as get, post, put, delete, and more. The library supports various authentication methods, cookies, sessions, and SSL/TLS encryption. The key features of the requests library include a user-friendly API for handling HTTP requests and responses, support for common HTTP verbs, various authentication methods, session and cookie support, seamless SSL/TLS encryption handling, and built-in JSON parsing, making it a powerful tool for interacting with web services securely and efficiently. The use cases of the requests library encompass a wide range of applications, including web scraping, API integration, authentication and authorization, data collection and aggregation, testing web services, making proxy requests, HTTP request manipulation, and performance testing. Up next is pros and cons of requests library. The requests library boasts several pros, including simplifying API for making HTTP requests, supporting common HTTP authentication methods, efficient handling of sessions and cookies, built-in support for SSL/TLS encryption and secure communication, and convenient methods for accessing response headers and content, etc. On the other hand, the cons of the requests library include limited support for asynchronous requests and heavy concurrency, requiring manual handling of request timeouts and retries, no built-in support for WebSocket communication, reliance on external libraries for advanced functionalities like connection pooling, limited efficiency in handling large file uploads, and more. Next, NumPy. NumPy is a Python library used for numeric computing. It provides efficient multidimensional array objects and functions for mathematical operations. With its powerful array manipulation capabilities, NumPy is widely employed in data analysis, scientific research, and machine learning. It serves as the footing for developing various other scientific and data-oriented Python libraries. NumPy has become essential for performing advanced numerical computations in Python with the functionalities like array indexing, slicing, and linear algebra operations. Moving ahead, NumPy's key features include providing efficient multidimensional array objects for numerical computing, offering a wide range of mathematical functions and operators for element-wise operations, supporting broadcasting, and providing flexible indexing and slicing capabilities. It also includes comprehensive linear algebra functions, seamless integration with other scientific Python libraries, and fast and efficient computation due to its optimized C code implementation. Let's talk about the use cases of NumPy. It encompasses data analysis and manipulation, scientific computing, machine learning, financial modeling, computational physics, data visualization, robotics, and bioinformatics. NumPy offers several pros, including high performance, broad functionalities, seamless integration with the Python ecosystem, memory efficiency, and extensibility. However, there are some cons to consider, such as a steep learning curve, limited flexibility, the presence of the global interpreter lock, limited GPU support, and a somewhat complex API. Next on the list is Pandas. Pandas is a Python library used for data manipulation and analysis. It offers high-performance data structures like data frames and series, along with functions for data visualization and transformation. It provides powerful data indexing and slicing, handles missing data efficiently, and seamlessly integrates with other Python libraries like NumPy and Matplotlib, making it a valuable tool for data-centric workflows. Moving on, Pandas offers key features such as data frames for efficient manipulation and analysis of structured data, data cleaning and handling of missing data, data transformation operations, flexible indexing and slicing, time series analysis, integration with other libraries, data visualization capabilities, input/output support for various file formats, and flexible data structures. The use cases of Pandas include data cleaning and pre-processing, exploratory data analysis, data wrangling and transformation, time series analysis, financial analysis, machine learning and data modeling, business intelligence and reporting, and data visualization. Pandas offers several pros, including being powerful and efficient for data cleaning, transformation, integration, exploration, and analysis. It is widely adopted and supported in the data science community. However, there are some cons to consider, such as a steep learning curve, memory usage, performance limitations, limited support for big data, and API complexity. On number 11, we have Pillow. The Pillow is a popular Python library for image processing and manipulation. It provides a wide range of functions and methods for opening, editing, enhancing, and saving images in various formats. The Pillow supports basic image operations like cropping, resizing, rotating, and flipping. It also offers advanced image processing capabilities such as filtering, blending, and color adjustments. With Pillow, you can handle image metadata, apply text and graphic overlays, and perform image format conversions. Pillow, a comprehensive Python imaging library, offers a wide range of features for image manipulation, enhancement, filtering, format conversion, metadata access, and text, graphic overlays. The use cases of Pillow include image processing and editing, web development, machine learning, digital media and content creation, data visualization, and scientific research and analysis. Pillow offers several pros, including comprehensive functionalities, support for a wide range of image formats, ease of use and installation, active community support, cross-platform compatibility, a wide range of image manipulation operations, and extensibility with plugins. However, there are some cons to consider, such as the lack of detailed documentation, limited support for advanced image processing techniques, slower performance compared to specialized libraries, high memory consumption, limited performance compared to lower-level image processing libraries, limited support for deep learning image processing, and limited GPU support. Another one on the list is TensorFlow. An open-source machine learning framework termed TensorFlow was created by Google. It features strong support for deep learning and machine learning, as well as a modular numerical computation core that is applied across many different scientific fields. Using several platforms, including but not limited to CPUs, GPUs, and TPUs, is made simple by the flexible design. Multiple layers in the deep learning models allow for the learning of complicated patterns and data representation. TensorFlow's key features include graph-based computation, automatic differentiation, cross-platform scalability, a rich ecosystem with pre-trained models and datasets, TFX for end-to-end support, and TensorBoard for visualization during training. The use cases of TensorFlow encompass image classification, object detection, NLP, anomaly detection, speech recognition and synthesis, recommendation systems, time series forecasting, generative models, reinforcement learning, robotics and control systems, and healthcare and medical imaging. Pros of TensorFlow are its versatility, scalability for distributed computing, rich ecosystem and community support, TensorBoard for visualization, deployment flexibility, and production-ready tools. Cons of TensorFlow include a steep learning curve, verbose syntax, documentation issues, performance overhead, and limited mobile support. Next one we have scikit-learn. Scikit-learn, also known as sklearn, is an open-source machine learning library for Python. It provides a comprehensive set of tools for various machine learning tasks, as it is built on NumPy, SciPy, and Matplotlib. It is designed to be user-friendly, efficient, and accessible to both beginners and experienced machine learning practitioners. Scikit-learn's key features include a diverse set of algorithms for classification, regression, clustering, and dimensionality reduction, tools for data pre-processing and feature engineering, model evaluation and selection functions and metrics, seamless integration with data pipelines, interoperability with other Python libraries, and extensibility for custom machine learning algorithms. The use cases of scikit-learn cover classification, regression, clustering, dimensionality reduction, model selection, pre-processing, NLP, time series analysis, and ensemble methods. Pros of scikit-learn are its wide range of machine learning algorithms, comprehensive documentation, ease of learning and user-friendliness, seamless integrations with other tools, robust model evaluation and selection, and active community support. Cons of scikit-learn include limited deep learning support, constraints in scalability for large datasets, lack of distributed computing support, potential performance limitations in certain domains, limited customization options for algorithms, and relatively slower execution speed. On number 14 we have PyTorch. An adaptable and effective framework for creating and training neural networks is provided by PyTorch, an open-source deep learning toolkit for Python. It offers smooth model building and optimization using a dynamic computing graph and GPU acceleration. Backpropagation is made easier by its automatic differentiation feature, which also seamlessly connects with the Python ecosystem. PyTorch is a popular research tool that offers resources for model deployment in real-world settings. PyTorch's key features include its dynamic computation graph allowing flexible model architecture changes, efficient GPU acceleration, automatic differentiation, a collection of pre-built neural network modules, seamless integration with the Python ecosystem, and popularity in the research community for experimenting with novel model architectures. The use cases of PyTorch encompass image classification, time series analysis, research and prototyping, transfer learning, generative models, natural language processing, object detection, and segmentation. Moving on to pros of PyTorch include its dynamic computation graph, efficient GPU acceleration, automatic differentiation, extensive neural network modules, Pythonic interface, research-focused framework, and model deployment tools. Cons of PyTorch are its steep learning curve, less mature ecosystem, requirement for more low-level coding, limited built-in support, relatively slower execution, fewer trained models available, and a smaller community compared to some other frameworks. Last but not the least, OpenCV, open source computer vision. OpenCV is a widely used open source library for computer vision and image processing tasks. It offers a comprehensive set of functions and algorithms that enable tasks such as image and video manipulation, object detection and tracking, facial recognition, and real-time computer vision applications. OpenCV supports various programming languages, including Python and C++, making it accessible and versatile for a range of computer vision projects. OpenCV's key features include a wide range of image and video processing functions, pre-trained models for object detection and recognition, tools for feature extraction and matching, camera calibration capabilities, seamless integration with machine learning frameworks, real-time application optimization, cross-platform compatibility, and strong community support. The use cases of OpenCV encompass object detection and tracking, facial recognition and biometrics, augmented reality, video and image recognition, robotics and machine vision, medical imaging, and gesture recognition. Moving onwards to pros of OpenCV include its wide range of functions and algorithms, extensive algorithm collection, real-time capabilities, cross-platform compatibility, large and active community, multiple language bindings, integration with machine learning, and being open source and free. Cons of OpenCV are its steep learning curve, limited deep learning support, lack of high-level abstractions, relatively low-level programming, limited documentation, suboptimal performance, lack of built-in GUI support, and limited support for 3D computer vision. Now that we have explored an impressive lineup of Python web frameworks and libraries, it's time to make the right choice for your project. With countless options at your disposal, the selection process can be overwhelming. However, by keeping a few essential factors in mind, you can confidently make an informed decision. Let's take a look at some key considerations to guide you on this journey. First and foremost, ensure that the library you choose aligns perfectly with the purpose and requirements of your project. Carefully examine its documentation to see if it offers comprehensive and up-to-date information, saving you time and effort in understanding its functionalities. Next, the size and activity of the library's community play a crucial role. A strong and active community can provide invaluable support, answer your queries, and contribute to the library's development. Maintenance history and the frequency of updates are also vital aspects to check. An actively maintained library with regular updates is more likely to stay relevant and provide bug fixes, new features, and compatibility with the latest Python versions. Popularity and adoption should not be overlooked. Popular libraries usually have a larger user base and are more reliable, well-tested, and actively maintained, with plenty of community resources and third-party integrations available. Compatibility is essential, so make sure the library works seamlessly with your Python version and platform. Performance characteristics are critical, depending on your project's requirements. Look for benchmarks or performance comparisons to ensure optimal performance. Check the license under which the library is distributed, ensuring it aligns with your project's needs and that you are comfortable with its terms. Examine the library's dependencies and consider potential conflicts with other libraries you are using. Libraries with minimal or well-managed dependencies are generally easier to integrate. Lastly, read reviews and recommendations from fellow developers or experts who have used the library. Their experiences and insights can offer valuable information about the library's strengths, weaknesses, and suitability for your specific use case. And there you have it, fellow coders. We've embarked on a thrilling journey through the world of Python frameworks and libraries, uncovering powerful tools that can elevate your projects to new heights. From Pyramid to the lightning-fast bottle, and the agile Acrobat Flask to the champion of asynchronous web apps, IOHTTP, we've explored an incredible lineup. There's more. For in-depth insights, be sure to visit our blog. We've crafted a treasure trove of knowledge, just waiting for you to explore. Our blog delves deeper into the intricacies of each framework and library, giving you the edge you need to make the right choices for your projects. But wait, our journey doesn't end here. Our team of skilled developers is ready to join you on your coding adventure, offering their expertise and assistance to bring your projects to life. Whether you are looking to build a web application, a RESTful API, delve into data science, or create mind-blowing machine learning models, we've got you covered. Our passion for coding and innovative solutions knows no bounds. So, if you're in need of a helping hand or simply want to explore the vast world of Python even further, reach out to us. Egloword hopes you enjoyed and learned from this program. For more details, go to www.egloworditsolutions.com Thanks for listening.